Hello, everyone. Welcome back. We're going to move on to lesson 2 of Unit 1. And what lesson 2 of Unit 1 is about is to introduce you to the concept of what we call a geometric sequence. So, a geometric sequence is a special type of sequence in which the pattern is to multiply or divide by the same number each time. If your pattern is to multiply or divide by the same number each time, we call that a geometric sequence. And that number that you multiply or divide by is called the common ratio. That's an important term, the common ratio. And we can find the common ratio by dividing any term of the sequence by the previous term. So if I have a geometric sequence, I can figure out the common ratio by dividing any term of the sequence by its previous term. All right. Now, the thing you want to note is if the pattern is to divide by the same number, we say that the common ratio is 1 over that number. Okay. What I mean here is to look at these examples here. So this first example is a simple example. We have a sequence in which our pattern is to triple each time, to multiply by 3. 2 times 3 is 6. 6 times 3 is 18, so on and so forth. So we can clearly see that the common ratio is 3. And here, find the common ratio by dividing each term by the previous term. So if I do 6 divided by 2 or 18 divided by 6, what do I get? I get 3, the common ratio. So we would say that in this case, the starting term is 2, and each new term is 3 times the previous. Okay. Now, this second example here is a little different. Now, instead of tripling each time, instead of multiplying by 3, we're actually dividing by 3 each time, right? 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1, so on and so forth. So in this case, the pattern is to divide by 3. So notice we say that the common ratio is 1/3. We don't say that the common ratio is 3. Okay? So you can see here, if the pattern is to multiply by 3, the common ratio is 3. But if the pattern is to divide by 3, we say that the common ratio is 1/3 or 1 over that number. The last important characteristic of a geometric sequence is that its graph is exponential in nature. So I have off to the side here an example of exponential graph that is increasing, and I have an exponential graph that is decreasing. Okay, so if I were to graph, for example, this first sequence here, it would look very similar to this first graph up top. If I were to graph this second sequence, the one where we're dividing, where we're decreasing, multiplying by 1/3, we would say, and we were to graph it, we would say that it would look very similar to this second graph right here. So that's a geometric sequence. So let's go ahead and take a look at the examples for this lesson. So we have here a few examples of a geometric sequence. So for each geometric sequence, find the missing values and find its common ratio. What I always like to do is I like to try to figure out what the pattern is. If I can figure out what the pattern is, then I can do these two things. I can find the missing values and I can find its common ratio. So this first one here, I start at 1.5 and I go from 1.5 to 3 to 6, so on and so forth. It looks like we're multiplying by 2 because 1.5 times 2 is 3 and 3 times 2 is 6. So if I were to continue that pattern, then that first question mark would be 6 times 2, which is 12. and 12 times 2, which is 24, and 24 times 2, which is 48. So I found the missing values, and my common ratio, which I'm going to abbreviate CR, the common ratio is clearly 2 in this case, since the pattern is to double. Okay. Number 2, so we go from 40 to 120. 40 to 120, looks like we're multiplying by 3 this time. Okay, 40 times 3 is 120. 120 times 3 is indeed 360. So this one is a little tougher. You may need to use a calculator. You can use the calculator on your phone if that's what you want. If you want to use the calculator on your computer, that's fine. You could also use Desmos. I'm going to use the one on my phone. So 40 times 3 is 120. 120 times 3 is 360. 360 times 3, okay, is 1,080. And again, I just use the calculator on my phone. And then 1,080 times 3 is 3,240. So those are the missing values. And again, my common ratio, okay, our pattern is to multiply by 3 each time. So my common ratio is 3. Okay. Let's take a look at number 3. Now we're decreasing. We go from 200 to 20 to 2. So clearly my pattern is not going to be to multiply, it's going to be to divide this time. So the question is 200 divided by what is 20? And it's clearly going to be 200 divided by 10. Right? If I take 200 and divide it by 10, do I get 20? Yes, I do. Is 20 divided by 10 equal to 2? Yes. So we could go from there. So 222. So that first question mark is going to be 2 divided by 10. And again, if you can't do it in your head, there's no shame in using a calculator. So 2 divided by 10 is going to be 0.2. So the question is 0.2 divided by 10 equal to 0.02? And I just did it on my calculator, and it indeed is. So 0.2 divided by 10 is 0.02. And 0.02 divided by 10 is going to be 0.002. So those are the missing values. The question is, what is the common ratio this time? All right, we're not going to say the common ratio is 10, because a common ratio of 10 would mean that we're multiplying by 10. Since our pattern is to divide by 10, we're going to say that my common ratio is 1/10. 1 divided by 10. All right. And the reason is because, think about it, dividing by 10 is the same as multiplying by 1/10. Just like dividing by 2 is the same as multiplying by half. Dividing by 3 is the same as multiplying by 1/3, etc. All right, last one here. What does it look like we're doing? We go from 24 to 12 to 6. So it looks like we're halving each time. We're dividing by 2. That's our pattern. So 24 divided by 2 is 12. 12 divided by 2 is 6. So 6 divided by 2 is going to be 3. And 3 divided by 2 is 1.5. So those are our missing values. And again, my common ratio is not going to be 2. Common ratio of 2 would mean that I'm doubling. We're going to say that my common ratio is 1/2 or 1/2. Okay, and that is it for the examples and also the end of lesson 2.